Hello, everyone. Can everyone hear me? All the way in the back? Yeah, somebody in the back wave to me. Yeah, perfect. Thank you. So yes, I am incredibly excited to be here today to be part of the GraphQL community. It is absolutely amazing seeing the adoption curve of this technology. GraphQL is only a few years old, and yet it seems to have taken off in a way that I've not really seen many other technologies gain the sort of adoption that GraphQL has. Looking around here just at this conference, the breadth of industries and companies that is represented and the depth of investment that folks are making into GraphQL is it's absolutely fantastic. And it's really heartening to me as I continue to dig into GraphQL and explore the different options that are available there. Personally, I started as a GraphQL skeptic. I tried things out on the client side, and I thought, this is fantastic. I love this, but I imagine somebody on the server side is going to have to pay the bill. This is a more complicated thing to do. And yet, the deeper that I dig into this world, the more that I think GraphQL is actually one of the more fundamental and needed changes in the world of technology that we've seen in many years. Obviously, that's somewhat of a lofty claim, but I'm amongst friends here, so hopefully you're all roughly in agreement with that. In this talk, I want to explore some of the architecture and philosophy that undermines all of GraphQL. I want to do it through the lens of client-side development, but I think we'll be talking about bigger things as well, both in the server and then the way GraphQL can inform our systems. So very briefly about me, once again, my name's Chris Toomey. I work at a development consultancy, development and design called thoughtbot. And you can find me on the internet at Twitter. I'm at Chris Toomey. And I also host a podcast called The Bike Shed, which is @_bikeshed on Twitter. Now, working at a consultancy, I think actually looking at the majority of the talks, that's actually somewhat different than most of the other things that we've seen. There are a lot of folks coming from product companies, working on a little bit more focused in a particular domain or industry. But by virtue of working at a consultancy, I get to see a cross-section of different problems, of different technologies, of different businesses, of different industries. And uniformly, I think GraphQL is a technology that can help in almost all of these cases. Now, the reason why I think this is we're going to take a little bit of a historical journey here together. Way back when, let's say 10 years ago, so eternity in internet years, applications were much simpler. We had a single application, it probably had a database, it rendered some HTML, sent that down to the browser, and then we just kind of did that on a loop. This was a simpler time. This was an easier time to build things, but over time things have moved. Just an aside, some people may call this the monolith, both in better or worse terms, depending on how you consider that. But over time we've seen a transition from these simpler applications to platforms. So at a minimum, it's pretty much table stakes at this point to have an iOS app. Not a requirement, we can get away with mobile web, but in a lot of cases, an iOS app is pretty much a requirement. Additionally, then, we may want to see additional behavior in our web apps. We want to see more performance, we want to see better interactive things, closer to what we're experiencing in iOS apps and mobile. So we're starting to fracture out our world. Again, still, maybe we're connected to the monolith, but this keeps expanding. And the more I look at companies out there, the less I'm seeing it's a simple CRUD app for project management. That's it. It's very straightforward. More what I'm seeing are platforms. We have Airbnb, which is a platform for connecting folks with places to stay and folks who want to stay there, as well as supporting back-end teams that need to curate and manage all of that content. So each of those are different facets on the data that we have, different points of view, and each of them also may have an iOS app, an Android app, a web app, or maybe even multiple of them. So we're seeing this fracturing of clients, which I think is potentially a good thing. This allows for more purposeful experiences, better workflows for the users, but it is complexity. I think we can't really argue against that. Having more clients, having more things that need to understand how our application works is a more complicated world. Similarly, on the other side of the aisle, we're seeing a transition from traditional monoliths, single sources of truth, into a fracturing of services. Here I've represented what a potential organization of that might look like, and this, to me, is probably the most concerning version of how this can play out. We have a number of client applications talking to both the central monolith, but also to some of the services. We have even bidirectional communication between some of the services and the clients. And even just from a mathematical standpoint, this is more complex. Now, I want to pause here and switch over to, instead of thinking about it in terms of architecture, I want to think about this in terms of technology. Running the clock back about those 10, 15 years ago, We implemented the vast majority of our logic on the server side. We're rendering HTML, we send that down to the client. Now, if we tick the clock forward a few years, we decide we want a little bit more behavior out of our systems. We want a little bit more interactiveness, we want animations, things like that. And so jQuery came along, and at the time, jQuery was an absolute godsend because it provided some organization, some common behavior across the different browsers, and it allowed us to push more of our logic to the client side. And I think this was largely a good trend, but then we kind of kept moving. Backbone, personally, was the next thing that I moved on to. Spent a few years in Backbone land, and again, moving more of our work to the client side. At this point now, we're rendering templates on the client side. Actually, a good portion of the logic of our systems has moved. And then as we keep going, Ember and Angular were sort of the next incremental step here, really pushing that logic over to the client side. Alongside underpinning all of this would be, obviously, the adoption of REST APIs and the proliferation of those, which, again, are not necessarily bad in and of themselves. The final step, the most recent one that I at least personally worked on, was React and Redux. And as I first started to work with them, I found them to be a breath of fresh air. React and its the view is a function of the data. I absolutely love that. Redux provided a clarity in the way that we're manipulating state. But if we're being honest, it was a lot of code and a lot of logic that still lived in our systems. Now, this isn't inherently a bad thing. I don't want to push any judgment onto this. But when we look at it in the context of what was happening architecturally, I think it becomes a problem. When we have the fan out of all of these clients and potentially the complication of splitting out our backend into many services and encouraging communication between them, this is far too much complexity for clients that are already owning too much of the logic to take on. So coming back to our technology, for the first time in a long time with GraphQL, I think we've seen a shift back. We've taken some of that logic that was being implemented on the client, and specifically in each of the different clients that we had, and we've been able to push it back to the server. GraphQL provides us a different layer, a different place to house that logic. And I cannot stress enough how happy I am that this is the world that we get to live in now, how meaningful of a change that I think this is. So this is what it looks like in terms of the architecture diagram. We've now introduced GraphQL as the single central API. It's that gateway. This is a common theme that we've seen throughout the talks at the conference so far. And actually, I like to take it one step further, which is let's hide all of that backend stuff. So not only have we provided that choke point, the fan in and fan out of the GraphQL API there in the middle, but we can actually use that to truly hide the backend from ourselves. And we've heard this repeated as a best practice from a number of different folks throughout the conference. Do not let your GraphQL API reflect the structure of the database tables, the services, et cetera. Use the GraphQL API as a point to think about the design of your domain. What is true about your platform? And again, this all speaks to the transition that we've had from applications to platforms. At its heart, we still need to provide slices of the same big data piece to each of these clients, but they want slightly different versions. That doesn't mean we necessarily want to fracture that out into the different services, or at least not expose that to the clients. So now, with all of that in mind, we can take a look at some of the fundamental aspects of GraphQL and see how they affect all of this. So one of the core pieces of GraphQL is the idea that you get what you ask for. Rather than in REST, you hit an endpoint and you get back whatever data. With GraphQL, you explicitly request the fields that you want and only the fields that you want. Often we talk about this in terms of performance. This is very useful because it reduces the size of the payload coming back from the server. But frankly, I am much more interested in this because of the freedom and ownership that this gives the client. The client is able to say explicitly, declaratively, this is what I need. The server actually gets some benefits out of this as well because it knows the fields that are being used. With REST, it was largely a black box. We didn't know what fields anyone was using, and so every change potentially could be a breaking change. But with GraphQL, we get a much more meaningful conversation between the client and server, and we allow each client to own the little piece of data that it needs. It seems to have left us now. The next piece of the GraphQL picture that I really think is interesting is getting related resources in a single query. Now again, a lot of focus with this is often on performance. This allows us to reduce the number of round trips, which can be incredibly impactful for especially mobile clients, but in general, if we can make one request and get all the data that we need, that's going to be better. But I'm actually much more interested in it from a complexity standpoint. If we needed to fan out and make multiple requests, especially multiple dependent requests, first get the information about the human, then we have a bunch of IDs, send those into the other backend to get the starships, and then we need to merge all of that data together. That's data manipulation, that's data handling, that's orchestration that every single one of our clients needs to do. But with GraphQL, we're able to move away from that. And lastly, we have the schema and the type system. Probably my favorite feature of GraphQL, the fact that it is so core and central to the whole thing. This lets us provide a common language for what is true about our domain. What can we do? What can we ask for? How can we change things? And what are the different variants of how we can do all of those things? All of this is fantastic, and it allows for, or I think it supports the idea of having small, focused clients that can each do what they want well, but can vary independently because we have this strongly typed contract between the server and the clients. So with that as some context, I have a sample app that I've put together, which is on this screen. So this is going to be the app that we'll work through as sort of a case study of some of these pieces in practice. It's a very simple app, but I think it's just enough to give us something to talk about. So to start, we have a search bar here. This is connected to the GitHub GraphQL API, and I can type in my name, run search, and you'll see that we'll populate out here with a few tiles, one for each of the people. That person happens to be my brother, irrelevant, but just thought I'd share. I can also load more, and so down here we get pagination. All of these things fall pretty naturally out of React and Apollo. Apollo is the framework that we're using behind the scenes here, and we'll dig into that in just a second. But now for any of these users, I can go ahead and click on them, and here we have the summary of me. So we have my login, we have my name, description, we have the organizations that I'm part of on GitHub, and then we have a list of all of the repositories. I'll zoom out just a little bit. Those of you good with pattern matching will notice that I spend far too much time writing Vim script. This is not a thing that I recommend anyone do. I swear that I do write other things in Vim script, but this is actually my most popular repositories. I'm mostly known on the internet for writing Vim script, so maybe today we'll change that. But there's actually one down here which is Ruby, but if you look closer, actually it's a Vim plugin that just happens to be written in Ruby, so it's aside from the point. But if we look at these, at first they seem like relatively simple pieces of data, but actually there's a lot going on here. So each of these has a link, it has the title, it has the description, it has some metadata about the repository, including the proper color of the language that is represented. We've got the fork count, the star count, and then lastly we have the ability, this is the only piece where we can actually change data, but if I come up here and I click the unstar button, we get a loading state, and now we've changed the state of that button, and also if you see down here, so that's 2312, if I start, it's 2313. So we'll look at how that's implemented, but I just wanted to give the framework of the actual application itself, and now we can come in here and dive in. So the first thing that is interesting to me with GraphQL and with React particularly, and we're going to use React as the test here and Apollo client. None of these things are truly specific or require those technologies, but they happen to work extremely well. It'd probably be weird for me to use anything else than Apollo at this conference, but I am a huge fan of it, and I think it really does a great job. So by virtue of all of these pieces that we've talked about with GraphQL, by the consistent structure that it provides, this is all of the configuration that we need. We're able to set up the client, basically just pointed at the URL. There's a little bit of auth logic in there, but that's it. If we think about a REST API, we would have to manage all of the different endpoints, think about how we're destructuring the resources. There's actually caching going on behind here. There's management of error states. There's a lot that Apollo can do for us just by convention based on the GraphQL standard. Now if we jump down here, this is the outer shell of the whole app, and we're able to just provide that configured Apollo client in, and everything's great. That's the entirety of the configuration, and I absolutely love how simple that is, how little code was necessary to actually get up and running. So now as we dig in, this is the first component that we'll be taking a look at. This is the user list. So if we come back to the app, this is this whole page here, so not including the search bar, but the whole list of results down here, including the load more button. So that's what we're looking at right now. And again, we're able to see very little code, which I think is a great thing. But perhaps most importantly is the fact that we're able to co-locate the query beside the component. Now I'm guessing this is common for most of you folks doing this, but this is still something that I haven't quite gotten over, that I'm still extremely excited about. This would be impossible in a REST system because each component would then have its different view of the world. This is really only possible in the context of the type system that GraphQL provides. And to highlight that, if we jump down here, what we're doing is we're running a search. We're specifying the number of people that we want, the actual search string that we're using. We're refining it down to the type of user. And then from there, we're actually doing, there's a little bit of pagination info. But what's interesting is if I introduce a typo, ESLint is running in the background. It's looking at my schema, and it's able to live tell me no, this is not acceptable. You've produced a typo here, and even give me the wonderful, did you mean name? I did mean name. Thank you, ESLint. That's so nice of you. This would be impossible, again, in a REST API. Or not impossible, but incredibly difficult. I've tried to do similar things with JSON schema and other documentation tools, but it always ends up being a ton of work and rarely correct or rarely consistent for that long. But because the type system is core to GraphQL, this just sort of naturally falls out. The same sort of thing is true if we jump up here. If we make this into a string, that's going to highlight that we have an invalid value. If I typo here, same sort of thing. So we're able to get deep validation of these queries, which is really the only way that it would be possible to have them spread throughout your code base. The idea that they're living alongside each component, it's only possible in the context of this sort of validation. But as we take a little bit broader of a look, if we come up here, we now have that query defined. We're able to use it. Apollo provides us the wonderful query component and leans into the render prompt pattern. But that's sort of irrelevant in my mind. What I like is this center bit. This is all of the code necessary, that configuration, and then this page to render that list. There's a lot of behavior that's inherent in all of that, and it's incredibly little code. It's very direct. It's the code that I would use if I were to describe to another human, well, I want to search and get all the users that match the search string, and then I want to render them each into a little tile on the page. And that's basically exactly what we have here. That just sort of naturally falls out of GraphQL and out of React and Apollo. But this really, to me, this is the simplicity that I see here, especially in contrast to things like React and Redux. That pattern before where there would be actions and whole cycles and many different files that I needed to edit. The fact that everything I need can live in this single file is fantastic. Now, all that being said, there is one thing that I do want to highlight, which is, if I come back down, let's see, to the word name there, if I search, you'll just have to trust me, I'm searching the file, and I'm only finding one instance. I'm talking about the name here, but why? Nobody else cares about the name. Why is this in my query? It turns out the answer to that is the user tile. So it's that little component that we're actually rendering in the list. That's the piece that cares about it. But now my parent query has to own that. So in the previous talk, we actually heard a couple different options. But the one that I've become most fond of is the idea of using fragments. So this is a core piece of the GraphQL language. And in the same way that we had with the parent query, if I introduce a typo here, this is not just an extra string of text that we're going to pass into a parent query, but this is a fundamental piece of the syntax of GraphQL. And so with this, we're able to break out the data needs of this subcomponent, let them own the specifics that they want, and then if we come back over here, let's see, if I jump down here, I can actually bring that in, user tile.fragment, and then we can change this section here to just reference that, and ideally, everything should still work. I think it all still worked. Hot modular reloading makes it hard to tell, but that was great. So what's interesting, and actually, this was slightly ahead of us, so let's go ahead and change that. Subtly, something actually changed there, which I'm going to change back now. Company is the word that we had in here, but we actually wanted that to be name. So I'm going to switch that back to name. Perfect. Now we can see there's my name, Chris Toomey. But now we'll actually undo that change. We can transition name over to be company at this point. Again, we get that same validation. We know that that's a valid field. If we save this, that's one single file that needed to change. No one else needed to care about that implementation detail. The parent query was left exactly the same, but the subcomponent was able to own that specific aspect of the data needs. Similarly, if I come up here and I change the 12 to 6, as I come back, we'll see that that list is reduced down from 12 to 6. And what I love about this is it allows for, again, that query collocation is incredibly powerful, but with fragments, we're able to take that one step further and say parent queries can own the specifics. So here we're looking at the parent query, and it says, these are the users that I care about. I'm going to actually not say too much about the details. I'm going to leave that to someone else. And then that child component, the fragment here, that one can say, I care about the details. This is what about each of those users that I care about. I don't care which user. I care about the what. I care about the which. We're able to bring those together and let each of these components own their own data needs. So this is a relatively simple example, but we can dig in a little bit deeper just to see what this looks like as we try and expand upon that idea. This is the user page query. So if we come back here, This paints this entire page. So this query is going to own all of the data from the very top, the image, and all of the header information, all the way down through each of the repositories. And the structure of this query is interesting because it leans on that fragment pattern even harder. So we can see here, there's the user header, the org, and the repo. Each are fragments that we're bringing in. Now again, I want to emphasize the pattern here of the parent query is describing which user, which organizations, which repositories. In this case, it's the user that happens to match the login that's being passed in. It's the first 10 organizations. I'm not actually that popular, so I'm not in 10 organizations. But if I were, or if I were in 15, we've now truncated that down and said something meaningful about which organizations. And then the repositories is by far the most interesting bit. All of that is a structured way of saying, give me the most popular repositories. So order it by stargazers, descending, make sure they're not forks, so these are actually my repositories, and give me the first 10. And then from there, we're able to let the subcomponents and their associated fragments own the data needs. So looking at that in particular, this is the user header, so this is the information about the user, and we can see this ends up being a leaf node. It just says ID, name, bio, et cetera. This is all the information necessary to populate that top section. Same sort of thing happens with the org. So for each of the orgs, I just want the ID, name, and the avatar URL so that I can render their image. But the repo is where things get interesting. For each of the repositories, this actually looks like a very small file, but it's encapsulating a lot here. We're actually going to split this out into two of its own fragments. So we've got the repo header and the repo stats. The repo header is giving the title and the URL and things like that. The repo stats is giving that lower bar. So all of the forks and stars and all of those sort of things. So we'll actually focus in on the repo stats here. We can see we can keep building on this pattern. So now down here on repository, we need ID, fork count, all of these pieces, and then primary language, which itself we go one level deeper. And now we're finally at language, which says I want the ID, the name, and the color of the language. All of this then gets composed back together into the one query that we need to run, and we're able to say a lot of meaningful things while allowing each of these components to own their data need, to change things locally, and not have to affect many different files. And again, that's painting everything that we see here. So this is fantastic, but we can even take this whole pattern one step further. If we look here, we now have the toggle star button. And one thing that I really like about this is just how simple this button is. It's encapsulating everything, and so I'm now putting it into my component tree by saying, I want the toggle star button. I don't care about any of the details. I don't want to manage any of what that means. I just want a button that allows me to toggle the stars. And so we're able to do that. It also does bring along its own data needs. So we've got here the toggle star button. That's saying whether or not the user is starred and what the star count is, so we're getting that information. And as we start to dig into it, the component itself has some interesting things. So at the top, we're switching between two different variants of the component, one to star and one to unstar. That largely is due to the structure of the GraphQL mutation that GitHub provides. But as we look at it, this is the actual component that does the work. Very similar to the query component, Apollo provides us a mutation component, which we can wrap around things. It yields us in a function, and now our actual rendering, the part that builds our UI, is very simply a button. We register an on-click handler that will fire that mutation. And we even pretty much for free get the loading state, which I was actually very happy to find as I was building this out. I was like, oh, that's nice. That's a nice freebie. Here we have the fragment that's associated with that. So this is all of the data necessary to initially paint the rendering of this, as well as for each of the two mutations. So there's the star mutation here and the unstar mutation. We actually want to re-up that information. This is one of the fantastic features of GraphQL that I actually don't hear folks talk about as much, but the idea that for each mutation, we can actually ask for data in return. We can do a query. The mutation will expose to us certain fields that we can then query into. And so in this case, we can ask for that data. Apollo is going to automatically update the cache, re-render any relevant pieces, and the UI just magically stays up to date. There's no imperative code here where I'm managing things and saying, oh, and also go update that other thing. I'm merely communicating with my server, having as simple a conversation as possible from the client perspective, and things just work. And now our whole button works. Now, this is a case where things get a little bit, this component is knowing a little bit more than it needs, because technically it doesn't need the star count in order to render itself. We're coupling a little bit across those two components. That said, because we know and we can validate these queries, that's a little bit of extra data that potentially could be wasteful if my other component were not rendered on the screen, but I'm generally OK with that. I'm OK with this component saying, like, and I know these things might change. It's just a little more data. Let's get that and ensure that we have an up-to-date view of the world. Now, all of this is fantastic, but we can go even further. And for that, I'm unfortunately going to leave Vim. As we've said, I really like Vim. But what I want to explore now is a TypeScript variant of this whole project. So I wrote the whole thing using JavaScript, and then I explored what would this look like if we were to transition it over to TypeScript. Knowing that we have the strong types in the GraphQL schema, can we leverage that, and can we get some value out of it? And the answer is very much so. We've heard this a few different times throughout the conference, but I'm going to show you now what exactly that looks like. So here I'm hovering over user.login, and very initially we can see that we get the information about the type, but there's a little extra thing here that I think is worth noting, which is the username used to log in. This is the description field coming from the GraphQL API. And this is just that one little bit of extra nicety that comes from having that centralized schema, defining our domain in that way, and then allowing that to flow through our system. So now we know that this is a string. That's fantastic. If we start to type in here, TypeScript and VS Code will do some magic, so I know that I can call the toUpperCase function because this is a string. This is great. But now if I jump back here, right now I have user dot, and now we can see these are the 4 fields that are available. So this is something that it knows, and we'll talk in a minute about how it actually knows that. But I can go through each of these options, and let's say I want to switch this over to name. So now I've switched it to name, and you'll notice that we get red squiggly underline. Something is wrong. And again, if we hover here, we can see the problem is that unlike login, which is definitively going to be there, name is nullable. Users do not have to provide their name via the API. So it's possible that this is a null field. And I don't want you to think that I'm just like making up things to demonstrate all of this. This is a real bug that I found in transitioning to TypeScript. The JavaScript version of the app is currently broken. I didn't really feel like fixing it, but the TypeScript version works, and this was a real thing that it found. As well as, I think the bugs are great, but the experience of using this is all defined from the query local to the component here, and being able to leverage that is fantastic. It just makes the developer experience, the discoverability, all of that so much better. So the place that this actually comes from, I've just opened up another file, which is a generated file. Apollo CLI allows us to produce this, and this is a specific interface, so a TypeScript interface, unique to the fragment that was located in this file. So again, that fragment decomposition allows us to break apart our code in an interesting way, but it even extends here into this type system. So we know that users have a whole bunch of fields that we can possibly get, but in this case, we know that we're only querying for these 4. So we get a type that is specific to that and gives us all of the information necessary to work directly with that piece of data within our system. So now we've explored the TypeScript thing. The last thing that I want to look at is if we think about the queries in total. What all did we do to paint that user page? Because that was the much more complicated query. So this is the actual query as it was rendered. You can see it's still got the fragments reference. So there's a bunch of fragments that were actually all folded up together. But if I then produce the logical inline version, I think there's some very interesting things that we can observe in here. The first is this repositories connection, this association. This has a very robust query language that is structured into it by virtue of the type system, by virtue of the schema. GraphQL allows us to say these sort of things. In a REST system, we would have to hit an additional endpoint. Maybe there's some parameterization there, but the idea of having this level of expressiveness, and in fact, GitHub's REST API, the V3 API, which is one of the best that I've ever seen, does not support this. This is not a question that I can ask of the REST API, but it just sort of naturally falls out of the GraphQL API. Similarly, and I think this was really well highlighted in the GitHub talk yesterday, viewer has starred these sort of computations. We don't want to meet the user exactly at the UI. We don't want to say should show button. But the idea that we can ask more intuitive questions. Viewer has starred. Viewer can star. Viewer can administer. Is fork. Is source. These are all things that are part of the GitHub GraphQL API that allow users, allow clients to more directly express the needs that they have for the data. And I think this is just fantastic. And in contrast to REST APIs, we always had the dual constraint of, well, anything we add in is bloating the response. Every client is now paying a tax in order for that new field to be in there. So do we really want to add it or not? Now, I don't think you should go completely wild with this and add everything to your GraphQL API. But the idea of adding things that are more user-centric, more client-centric, I think GraphQL really opens us up to that. And we can see that here with the viewer has starred. Similarly, primary language is a really interesting one. The GraphQL API exposes both languages, which is an array of language objects, and primary language, which is a single language field. Historically, that would likely have been, by convention, the first thing in the array is the one that is the primary language, or something to that effect. Similarly, the languages are actually exposed in the REST API just as strings, VimScript, Ruby, etc. So there was no way to get the color. This would just not really be possible, or in reality, the thing that we would do is every single client would actually have a local cache of VimScript is this color green, Ruby is this color red, Python is blue, yellow, something like that. But each client would need to own that data. We're then pushing all of that logic back out to our clients. But with GraphQL, again, we can sort of wrap our arms around it and pull it back to the server. Again, one last thing is all of the associations, all of the connections that we can make. Every edge that we add to our graph in GraphQL is an investment in the platform. Ideally, it's telling something that's true about your domain and about your modeling. So with that, I have a few parting thoughts, some of the things that really keep me coming back to GraphQL. I think GraphQL encourages and informs an architecture. As we're seeing the fracturing of clients and services, GraphQL gives us an answer. It's a relatively simple answer, but I think it's incredibly powerful, and I think it's one worth leaning into. In association with that, GraphQL introduces an abstraction layer for modeling our domain. When I first started working with GraphQL, I thought of it as REST, but better. REST, but I can ask for whatever I want, and I can have some associations. But what I find time and time again is that the questions and the conversations that I have with teams when we're building out GraphQL APIs are more fundamental. They are more focused on the product needs and on what's true of the platform, and less on, well, I'm going to serialize a resource now. I'm going to expose this data. So again, I think this is something to lean into, to take time with, and to be very careful with, because it can be a very valuable investment in the platform. And lastly, and perhaps most importantly, GraphQL encourages a product-centric approach. What we see are ways of defining our system and our platform that are useful to the clients, simplifications that make it easier for us to build our client applications. And I think that's the right place to invest in having the simplicity. It's right up where the users are. It's where the money is made. Ideally, it doesn't push too much complexity on the back end, but I think if we have to bias in one direction, a product-centric approach is always going to be the right choice. And I'm so excited that GraphQL has encouraged that throughout the community. And so with that, I thank you all for your time. I hope that was interesting and useful. Would love to chat with anyone in the breaks or over lunch, but thank you very much.